All right, here's a quick video tutorial on how to factor quadratic trinomials when the leading coefficient's not equal to 1. What I mean by that, quadratic means the degree of the polynomial is 2. Trinomial, meaning there's 3 terms here. And the leading coefficient, meaning the number in front of the x squared term, is not 1. It's 6 here, it's 12 down here. How do you factor those? Turns out it's pretty difficult. The most common method people use is a guess and check method. I don't like that because it can be problematic on quizzes and exams when you're just guessing. And I kind of like having a method that will always work when you go through the steps. There's a few steps here, but it turns out that it's not too bad. But it all relies on being able to factor by grouping. So if factoring by grouping is not something you're familiar with, you might want to watch that video before you watch this video because you'll need to do that in the 4th step. But I do have a video tutorial on that. The other note I want to make is if this is a 1, you can still use this same method, but it's much more difficult than a different method. There's a method, there's kind of a shortcut you can do if this is a 1 right here. Instead of a 6, this is a 1, and I have a video on that as well. This will still work. You could go through these steps and do this, but it's more work than you need to. So that being said, let's do it. Call the coefficient on the x squared term a, okay? So in this case, my a would be 6, because the coefficient on the x squared term is a. And the coefficient on the x term, I want to call that b. Might be like, wait, there is no coefficient here. Yeah, there is. There's a 1 that's implied here. You just don't write it. And the constant term, we'll call that c, is -2. Be careful. Make sure you don't write 2. It's -2 here. And then what we want to do is find two numbers that multiply. So we need two numbers that multiply to whatever a times c is. So a times c in this case is -12. And add to whatever b is. So be careful on if the leading coefficient is a 1, you kind of just look for numbers that multiply to -2. But here we want to find numbers that multiply to 6 times -2, -12, and add to 1. And the way you'll do that is, or the way I do that is I focus on the numbers that multiply to 12, because there's a lot of numbers that add to 1. 0 and 1, -1 and 2, 100 and -99. There's a lot, there's infinitely many. So it doesn't help to look for these, but if we can focus on just the integers, the whole numbers that multiply to -12, I actually look at +12 and then just think to myself that one of them has to be negative to make it -12. You can come up with this list. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. I'll show you a way to come up with this list at the end of this video if you have trouble doing that. So to multiply by -12, one of these two would have to be negative. -1 and +12. Those won't add up to 1. You can keep going through all the different combinations until you get down to the end here. If I choose -3 and +4, in my instructions I said to call those n and m. You don't have to label them as n and m. I just did that so I can refer to it later on in these steps. But what I want to point out is -3 plus 4 adds up to +1, and -3 times 4 multiplies to -12. So the two numbers that I'm looking for here are these guys. And once you find those, you're not done. When the leading coefficient is 1, when you find these two numbers, you're just about done. But in this case, you're not. That's just one step in the process. That's step 2, I guess. What you then want to do in step 3 is replace your middle term, your bx, your 1x here, with mx plus nx. So 4x minus 3x. What I want you to note is this is the same as this, because plus 4x minus 3x is the same as plus 1x. It's a different form, and this form will be easier to factor. Another thing I want you to notice is we could have said n equals 4 and m equals -3 and still get the same answer. This would have looked a little bit different. It would have said 6x squared minus 3x plus 4x minus 2, but it'll turn out you'll get the exact same answer. So what we're now done with is step 3. What we now have are 4 terms, and when you have 4 terms, you can use this factoring by grouping method. So again, if you don't know anything about factoring by grouping, watch that video, or watch me do it now. When you factor by grouping, so I'm down to step 4 here, what you do is you group. You say, all right, I got these two terms here, 6x squared plus 4x, and their greatest common factor is 2x. If I pull out a 2x from 6x squared, I'm left with 3x. If I pull out a 2x from 4x, I'm left with 2. What I'm saying is these two terms right here have a greatest common factor of 2x, and if I factor out that 2x, I'm left with 3x plus 2. My next step in factoring by grouping is to look for something from this other group that I can factor out so that I'll be left with 3x plus 2. I have to end up with the same thing in the parentheses. What can I pull out? It turns out it's negative 1 in this case. If I pull out a negative 1 from these two terms, I'll be left with 3x plus 2. And now what I have are two terms. Here's one of them, here's the other one, and each of those terms have this 3x plus 2 in them. So I can factor out that 3x plus 2. If I pull out that 3x plus 2 from this first term, I'm left with 2x. If I pull out that 3x plus 2 from this second term, I'm left with negative 1. And so what I now have is the factored form of this guy here. You can check your answer by multiplying these guys back together. I won't bother doing that, but you can if you want. I'll make another video on how to multiply binomials or polynomials back together. But nice check that's built into all these problems. So now let me do it again on a harder problem, really only harder because the numbers are bigger. And I'll go through it a little bit faster. I won't detail it like this. I'll kind of write it out how I'd actually write it if I were doing this problem. So if I were actually doing this problem, I'd first have to look at this and say, all right, I want two numbers that add to negative 29 and multiply to whatever 12 times 15 is. 12 times 15 is 180. The way you can get that is 10 times 15 is 150, but I need two more 15s. 2 times 15 is 30. So 150 plus 30 is 180. Anyways, I want two numbers that multiply to 180 and add to negative 29. Come up with this big list of the things that multiply to 180. Chose 180 because there are a ton of them. If you have trouble making this list, I'll show you at the end of the video how to make this list, or one way to make this list a little bit easier. But for now, I'll just kind of go through and come up with the, does 8 go in there? No, it doesn't, sorry. 7, 9. Doesn't work either, geez. Yeah, it does, 9 times 20. 10. As you can see, as I stumble through this, it's kind of hard to make this list right here. I think this is the complete list, but I'll show you how to do that later on at the end. But if you had this list, then you're like, all right, I want to multiply it to positive 180 and add to negative 29. A negative times a negative is a positive, so if both of these are negative, I'll get positive 180. And the way I can get them to add to negative 29, let's see, are there any in here that'll work? Here we go. Looks like these guys will work. Negative 9 and negative 20. So if I were writing up this problem, I would say, all right, what I have up here is the same as 12x squared minus 9x minus 20x plus 15. Negative 9x minus 20 more x is negative 29x. These are equal. But by splitting it up in this way, I'm guaranteed that it'll factor by grouping. And the way I split it up is by looking at these numbers here. My m was negative 9 and my, let's see, n was negative 20, if you want to really follow these steps. And then I'd factor by grouping. I'd say, all right, greatest common factor there is a 3x, and that will leave me with 4x minus 3. And if I want to be left with 4x minus 3 over here, I'd have to pull out a negative 5. Oops, 4x minus 3. And now what I have are two terms. They both have a 4x minus 3 in them. And if I factor out that 4x minus 3, I'd be left with 3x minus 5. So if I were trying to factor this, these would be the steps I'd show. And maybe I'd have this off to the side just to kind of show my work. And if you're not sure you did things right, you can multiply these back together and check your answer. I won't bother doing that. So I guess that's the end. I'm going to now show you how to come up with this list. I mean, this is kind of some bonus material here. One way to come up with a big list like this is to find the prime factorization. What I'm saying is 180. Think of any two numbers that multiply together to give you 180. The two that come into my head are 10 and 18. When something ends in a 0, 10 times something will get there. But you could have split it up differently. It doesn't matter. You'll get to the same answer at the end. And then you factor both of these numbers. You say, all right, give me two numbers that multiply to 10. 5 and 2. And what about multiplying to 18? 9 and 2. And let's see, 2 is prime, so I can't go any further. 5 is prime, I can't go any further. But 9 is not prime. 9 is 3 times 3. 2 is prime, so I can't go any further. So what I've done with this tree is I figured out the prime factorization of 180. And what's kind of amazing, one of the most important things in math, it's called the fundamental theorem of algebra. Is that true? I think that's true. Is that this prime factorization is unique. It doesn't matter how you split this up. I mean, your tree might look a lot different than my tree here, but at the very bottom here, you'll end up with the exact same thing. You'll end up with 2 different 2's. You'll end up with 2 different 3's. And you'll end up with the 5. These are kind of the pieces that make up 180. And once you know all the pieces that make up 180, you can make this list here. Say, all right, 1 times 180, that's easy. 2, let's see, maybe I need another color. Let's do this in red. 2 times this thing is also 180. And this thing, if you multiply these all together, you'll get 90. What else? Well, I could take one of these 3's and leave the rest of the pieces below, kind of behind. I could take 4. I could take 2 of these 2's here, this 2 and this 2, and leave all these pieces behind. These pieces would be 45, and here's the 4. 10, I could take this 2 and this 5, and what would be left would be this 2 and these 2 3's, 10 and 18. What I'm saying is you can get this entire list by thinking of all the different ways you can kind of partition these 5 numbers into 2 groups. So that's one way to come up with this big list, but really it's an aside. It's just a sub-step within the process. Really what I was trying to get across here is this factoring method, this kind of using factoring by grouping on quadratic trinomials when the leading coefficient is not 1. So I'll stop it there. That's the end of this video.